Okay, so first we had to figure out what STEM concept to teach, one not traditionally taught in K through 12 classrooms, and we had to explore the program itself to find the constraints so we know what we can or cannot do with a game within the program. Then we brainstormed different STEM concepts such as teaching projectile motion or flow rate, but flow rate seemed to work best within the constraints of Kodu because we found that we could program objects to lower the water. Then we gathered our poster materials and did some research on how playing games affects childhood learning, and we explored more of Kodu's possibilities, such as programming characters to have dialogue for formulas and dimension information, programming objects to lower the water, teleporting the user to different areas of stages. And this is our poster on FEDD Day. We then played the game numerous times to check for any type of bugs, like where the user may get stuck, and we also fixed a problem of the user possibly skipping all of the problems and teleporting to the other areas.
As with all of the groups that competed at FEDD, we were required to complete a research portion to supplement our project and also to present to the judges. Our guidelines stated that we must research childhood learning and development goals and use this research to support our choice of learning outcome and age range. A majority of our research centered on what would make a successful educational computer game. That is, what would make a game capture a child's attention and make them willingly teach a concept instead of it being a chore. A majority of our sources pointed towards an adapted difficulty that continually challenges players so it's not simply a skill and drill game, as was stated by one source. However, we ran into a problem of implementing a adaptive difficulty due to our want of this being a very accessible game where very much prior knowledge was not needed. While at FEDD, we were fairly well received by many of those who came to our table. Many seemed to be impressed solely by the 3D level design that we used. Although we did not have many who were willing to play and actually complete the calculations required, we did have several that wanted to play nonetheless. Despite this positive reception that we received, at the end of the day, we unfortunately did not place.
What design challenges did we face, and how did we address those challenges? We first had to decide on a STEM concept to teach. It had to be a STEM concept not traditionally taught in K through 12 schooling and could be taught through Kodu. We had to learn Kodu and work around the limitations of the program to teach our STEM concept. We explored the program and found out that there was a way to program water levels and came up with our idea to teach flow rate. We had to find a way to teach this concept through a game, use characters for dialogue, and to present the problem. The correct answers would lower the water, which would allow the player's character to proceed to the next level.
For an advice to next year's freshmen about FEDD project, plan. You should know what you're trying to get to before getting to the development stage. Plan before you go and plan as you go. While doing so, study Kodu, or the program you're creating your game with, first and thoroughly. That is to understand all the limits and border of possibilities. Sorry to say that, but you won't be able to do the next Halo. Even if you think you have the necessary skills to do so, Kodu has not. There is a universe of ideas. However, since we're talking about creating a video game, how you implement the idea can be more important than the idea itself. Also, try to meet up regularly. That will ensure completing what you have to do, or your milestones, and keeping track of the game development process.